Well, in the left side is the collection of curves for a particular specific gravity. Curves in the red color are called the falling curves because they keep on falling down when the separating temperature increases, and the ones in the green color are called the rising curves because they keep on rising when the separating temperature increases. And we have a vertical line representing the different gravity sizes, and to the rightmost we have feet rates in meter cube per hour. Now we will change the values of the variables one by one and see change in gravity sizes. Now let us vary the specific gravity from 0.92 to 0.96. Separating temperature is 40 degrees Celsius and the rate of feed 2.0 meter cube per hour. So we will change the specific gravity only. We know that the rate of feed is 2.0, this one. Separating temperature is at 40 degrees Celsius. We will mark the 40 degrees Celsius line. Firstly, we will trace the falling curve, this point. Next is to draw a parallel line from this point where it met the treating temperature line right up to the line for the 100 degrees Celsius. We have to draw another line right up to the 2.0 feed rate. Okay. The size of the gravities for 0.92, it is 71.25, and next we will see for 0.96. So we will keep the same temperature and the feed rate as before, only the change is in the specific gravity. So now the specific gravity falling curve is, now we will have to follow this curve. Now next thing is to draw a parallel line right up to the 100 degrees Celsius line. Next, we should not do the mistake of drawing the line parallel to the horizontal axis. Now, if we go along the horizontal path, we see that we are following the feed rate to be around 4.25 meter cube per hour. So this is the wrong process. So the correct process would be, we should now again connect the funnel line up to the same feed rate as you had drawn earlier for the 0.92 specific gravity. Well, after having drawn this final line, we can see that the size of the gravity disk matching the specific gravity of 0.96. Gravity disk size is 70.62. So when the specific gravity of the field increases from a lower value to a higher one, the size of the gravity disk has to decrease. That means the change in the gravity disk is opposite to the change in the specific gravity. The reason is very simple. When the specific gravity of the field increases, it imparts a greater amount of pressure onto the E line or the interface line, pushing the interface more and more outwards. So we have to create a counterbalancing pressure greater than the previous case where the specific gravity was lower, and that is possible by increasing the amount of the water rotating inward. By decreasing the inner diameter of the gravity disk, we can increase the width of the layer of the water rotating, and thus increasing the mass of the water increasing, and also increasing the back pressure from the water, which will now neutralize the increased pressure from the oil and make the interface steady at that place, so that the interface does not touch the outermost diameter of the top disk, and oil rushing out through the passage meant for the phase will be stopped. The fact that the increase in the specific gravity needs a reduced size of the gravity disk looks and sounds a bit odd, but it is true. It has to be understood this way.